In this video, we're going to look at topic 71, example 4, write the equation of a parabola given 3 points. What is the equation of the parabola that passes through the points negative 232, 15, and 317? Okay, so we want to remember when you have points, they're written in the form xy. And since this is the standard form section, we're probably going to be using standard form. And by probably, I mean we are. So you have y equals ax squared plus bx plus c. So what I'm going to do is I'm going to look at these 3 points. So first point is negative 332. The second point is 15. And my third point is 317. And what I'll do here is I'll take this negative 232 and realize that since they're xy, I can plug them into my standard form. So y would be 32, and x is negative 2. And what I'm trying to do here is I'm trying to create some equations that I can work with, and you'll kind of see the methodology or the reasoning in a couple minutes. But right now, you're going to take the values and plug them in as xy. Simplify your equation, so negative 2 squared would be 4, so I have 4a minus 2b plus c, or 1c. I'll just write it as 1c. So we'll call that equation 1. And you're going to do the same thing for equations for points 2 and 3. So y is equal to ax squared plus bx plus c. So 5 would be equal to a times 1 squared, b times 1 plus c. And simplify this. So we'd get 1a, 1b, and 1c. That one's pretty easy. And then equation 3, or point 3. Again, we're going to substitute these values in. So y is 17, x is 3. So I have 17 is equal to 3a. Sorry, that should be squared, so not 3a. It should be 9a. Can't read my own writing. And now I have 3 equations. You might realize that we can make these a system. And I can write these out as a system of equations. 1a, 1b, 1c, and 17 is equal to 9a plus 3b plus 1c. I'm going to rewrite this system with the values on the left and then the constant on the right. So that would be equal to 32. 1a plus 1b plus 1c is equal to 5. And at some point, you might kind of see where we're going with this and realize that if we have a system of equations, we can then use a matrix to solve for my unknowns, my variables. So we'll create that augmented matrix. These are ones. I know they don't look it, but so I now have this augmented matrix for negative 2, 132, 1115, and 93117. So once again, to get that, what I did was I took my x values from each coordinate point and I plugged them in to my standard form. Okay, so these numbers all here, these 3, 3, 1, negative 2, and negative 2. And then what I did with the y values is I plugged those in as my y value. All right. I then took my 3 equations, these 3, and I wrote them as a system. Okay, that system I then turned into a matrix. Once we have the matrix, we can then use technology and we can use a graphing calculator to solve for a, b, and c rather than have to do all that by hand. So what we're going to do is we're going to hit second matrix. We're going to edit matrix. In this case, I'll edit matrix A. I already have this typed in here, but normally this would not be filled out for you already. So you would make sure the matrix is the right size. So you would say 3 by 4, and then just fill in the respective points. right? So 4, -2, 132, and all that. Once you have that typed in, you can then quit that. Go back into your matrix, and we want to solve this. We're looking for the A, B, and C values, so we're going to go to option B, reduce row echelon form. Select the matrix that we edited, in this case A, and let the calculator do the work for us. So reduce row echelon form would give us these values here, and we'd have 3, -6, and 8. Now in the past we always worked with X, Y, and Z, but this time we used A, B, and C. So A is 3, B is -6, and C is 8. They asked us for an equation, so my equation is going to be in standard form, right? So this is the standard form section. So what I can do is I can plug in my values from A, B, and C, from my matrix as my A, B, and C values. So I can use A, which is 3, B, right, is that -6, and then C is 8 in this case. And I now have my solution. So y would be equal to 3x squared minus 6x plus 8. Sorry about that. That answers the question of what is the equation of the parabola that passes through the points -232, 15, and 317. Let's say you're really not sure if you did this correctly. What you're able to do is you can go to y equals on your calculator, type in the equation that you came up with, so 3x squared minus 6x plus 8, and you have two options. One will work pretty easily, one doesn't always, well, it works, but it's not always clear. If I hit graph, I can kind of see the 0.15 is on there, but 317 and -232 are way off the graph. I could do zoom, I could trace, but let's make our lives easier. Hit second table, and now I can scroll through and make sure my numbers match up. So -2 should match up with 32, which it does. 1 should match up with 5, it does. And 3 should match up with 17, which it does. So this checks out. Our solution is correct. Again, you can use the graph, but clearly if I look at my graph, I can't really see if -232 is on there. I could zoom, I could move things around, but just go to your table and make sure that the numbers match up. Okay. And that's it for that. So it does seem a little complicated, but if you realize it's just a series of substitution, rewriting that system as a matrix, and then using the calculator to solve that matrix, you'll pretty easily be able to find A, B, and C to plug in.